Good morning, students. Welcome to Engineer Drawing Tutorial, course code U18ME204, classroom discussion topic on types of lines. I am Rakesh, Assistant Professor in Department of Mechanical Engineering, CATIA Institute of Technology and Science, Warangal. Before enter into this topic, let us see the lecture outcome for this topic. After completion of this lecture, student will be able to discuss various types of lines in engineering drawing. Before going to discuss various types of lines, let us see what type of pencils are using for these different types of lines in engineering drawing. Let us see for initial work and construction lines we are using H pencil. For outlines or dotted lines or section plane lines or dimension lines or arrowheads, we are using 2H pencil. For center lines or section lines, we are using 3H or 4H pencil. You, you can see here 1H, 2H, 3H, 4H. When the number is increasing, the hardness is increasing. For example, you can take B pencil. B means for we are using for softness. That means for thick lines. When the number is increasing before the B letter, that means 1B, 2B, 3B, that means softness is increased. That's why, dear students, please purchase these two pencils. One is H pencil, another one is 2H pencil uh, for drawing any sketch in our engineering drawing. Let us see the various types of lines. The first one is continuous thick or continuous wide line. You can see the symbol. This is the continuous thick or continuous wide line. The general applications are for visible outlines, visible edges, crest of screw threads, limits of length of full depth thread, lines of cuts and section arrows, parting lines of molds in views, main representations in diagrams, maps, flowcharts, system lines, that is structural metal engineering. After completion of these various types of lines, I will show the practical application in engineering drawing. Let us see the second type. This is the second one, continuous thin. Thin means narrow, straight or curved lines. You can see this figure. This is the continuous thin or narrow line. The general applications are imaginary lines of intersection, grid lines, dimension, extension lines, projection lines, short center lines, leader reference lines, hatching lines, outlines of revolved sections, root of screw threads, interpretation lines of tapered features, framing of details, indication of repetitive details. The third one is continuous thin freehand line. You can see here. The general applications are limits of partial or interrupted views and sections if the limit is not a chain thin line. The fourth one is continuous thin with zigzag line. You can see this is the zigzag. The general applications are long break line. For example, the line length is 100 mm. in our practical we can draw only 50 ms, so that's why we can use this type of lines, that is continuous thin with zigzag lines. The next one is dashed thick lines. The general applications are lines showing permissible of surface treatment. The next one is dashed thin lines. The general applications are hidden outlines and hidden edges. Next one is chain thin long dash dotted lines. You can see here. The general applications are center line, lines of symmetry, trajectories, pitch circle of gaze, pitch circle of holes. Next one is uh, chain thin with thick at the ends and at changing of positions. You can see this type of lines in the section of solids. The general applications are cutting planes. Next one is chain thick or long dashed dotted lines. The general applications are indication of lines or surfaces to which a special requirement applies. The next one is, this is the last one, that is chain thin double dashed or long dashed double dotted. You can see here long dashed and double dotted lines. The general applications are outlines of adjacent parts, alternative and extreme positions of movable parts. That for example, that is locus lines for constructing locus lines. Centroidal lines, initial outlines prior to forming parts situated in front of the cutting plane. These are the various types of lines. Let us see the practical applications in engineering drawing. Here I am taking one figure and represented with different types of lines. Let us see the first one. Here this is the outline. Outline means lines are drawn to represent visible edges and surface boundaries of the object are called outlines or principal lines. You can see this is the visible edges. So here I am using continuous thick lines. The next one is dimension line. You can see this is the dimension line. Dimension lines means these lines are continuous thin lines. They are terminated at the outer ends. You can say terminated at the outer ends by pointed arrowheads. You can say this is the arrowhead. Touching the outlines, the extension lines are center lines. You can see this is the extension line and touching the center line. This is the center line. The next one is extension line. Extension or projection lines. These lines also continuous thin lines. They are extended by about 3 mm beyond the dimension line. You can see here. This extension is 3 mm beyond the dimension line. The next one is hidden or dotted lines. You can say this is the hidden line. Interior or hidden edges and surfaces are shown by hidden lines. They are also called dotted lines. They are of the medium thickness and made up of short dashes approximately equal to length of about 2 mm. This short line length is approximately 2 mm. The space between these two dashes is 1 mm. The next one is cutting plane lines. The location of a cutting plane is shown by this line. It is a long, thin chain line thick at ends only. You can see the Outside edges are represented with thick lines, inside part is thin line. The next one is center lines. You can see this is the center line. Center lines are drawn to indicate the axis of cylindrical, conical, or spherical objects or details, and also to show the centers of circles and arcs. They are thin, long chain lines composed of alternately long and dot spaced approximately 1 mm apart. You can see here the distance between this dot and dash, that is 1 mm. The long dashes are about 9 to 12 mm. This dashed line length approximately 9 to 12 mm. Center lines should extend for a short distance beyond the outlines to which they refer. You can see this is the extension of center line beyond that object. For the purpose of dimensioning or to correlate the views, they may be extended as required. The point of intersection between two center lines must be always be indicated. You can see. Let us see here. This is the one center line in horizontal direction. This is the another center line in vertical direction. We can represent with dot. Locus lines, extreme position of movable parts, and pitch circles are also shown by these type of lines. Let us see the uh, next figure. Here, uh, let us section line. It is also called as hatching lines. These lines are drawn to make the section evident. When we are cutting a part, we can represent with these type of lines. They are continuous thin lines and are drawn generally at an angle of 45 degrees to the main outline. You can see here the angle between each line 45 degrees with this outer line. This is the 45 degrees. They are uniformly spaced about 1 mm to 2 mm apart. The distance between this line to line is 1 mm to 2 mm. The next one is leader line. Leader line is drawn to connect a node with the feature to which it is applies. It is a continuous thin line. Here in this figure it's showing that this inner circle diameter we can represent with leader line. That means extension and give number diameter symbol and 10. We can also write text in this leader line. Here I am taking one more figure. The first one is short break line. These lines are continuous, thin and wavy. These are in the form of wavy. That means freehand lines. They are drawn freehand and are used to show a short break or irregular boundaries. Next one is long break lines. These lines, thin ruled lines with a short zigzag. You can see the symbol, this is the zigzag symbol. They are drawn to show long breaks. Already, already told in the initial slides. When we are representing uh, when this length is more than the given space, so you can represent with these long break lines. The next one is chain thick lines. These lines are used to indicate special treatment on the surface. You can see here, this is the chain thick lines. When we are doing any treatment on the surface, we can represent with chain thick lines. The last one is locus line. This is chain thin double dotted line. This is the brief discussion about various types of lines in engineering drawing. Let us see the summary of this topic. Various types of lines used in general engineering drawing are described by SP 46:2003. The thicknesses of lines are varied according to the drawing and are finalized either by ink or by pencil. Continuous thick lines are used for visible outlines. Continuous thin lines are used for dimension lines, extension lines, etc. Dashed lines are used for hidden outlines and hidden edges. Chain thin, chain thin, long dashed dotted lines are used for center lines. Dear students, let us see the reflections part 1 for this topic. The first question is invisible edges are shown by option A dotted lines, option B continuous lines, option C both, option D none. Dear students, please try to tell the answer for this question. Time up. The correct answer is dotted lines. This is the very important question. These type of questions are will come in your MSc 1 and ESE exams. Explanation. Invisible edges are shown by hidden or dotted lines. Interior or hidden edges and surface are shown by hidden lines. They are also called dotted lines. They are of medium thickness and made up of short dashes approximately equal length of about 2 mm spaced at equal distance of about 1 mm. You can see the symbol of in dotted lines. You can see the second one. This is the hidden lines. Next question, reflections part 2. In dimensioning, the lines enclosing the dimension line are known as option A leader line, option B dimension line, option C extension line, option D outline. Time up. The correct answer is extension line. Explanation. In dimensioning, the lines enclosing the dimension line are called as extension line. You can see this is the extension line. Next question, reflections part 3. The dashed line represents hidden edges, projection line, center line, hatching line. Time up. The correct answer is hidden edges. Explanation. The dashed line represent with hidden edges. Let us see the lecture outcome revisited. Having completed the discussion on types of lines, now students should be able to discuss various types of lines in engineering drawing. Dear students, you can refer the textbook that is N.D.BHATT, Eliminatory Engineering Drawing, Charter Publishing House, Anand, India 2017. The reading chapter number is 3.1. You can also refer this textbook that is Venugopal K. Engineering Graphics with AutoCAD. New Age International Publishers Limited, Hyderabad 2012. I hope this topic is very clear to everyone. Thank you for watching. Please do like and subscribe my channel for more videos.